So for this video, we'll be talking about basic divisibility rules, specifically from 1 to 11. So first define what divisibility is. So a number is said to be divisible by another number if their quotient has no remainder. So say if we have 60, we know that this is divisible by 6. Since 6 divided by 60, would give us a remainder of 0. Same for 10. So since we know that 10 divided by 60 is 6. Now we usually denote this by the symbol, this one. A divides B, or B is divisible by A, where A, B are integers and A is not equal to 0. A cannot be equal to 0, since if it is, this implies that B over A, or B over 0, which is undefined. Now, given the notation, we denote that by saying that B is divisible by 8. So, for our previous example, since we know that 6 and 10 divides 8, then we write that as 6 divides 60, 10 divides 60. If it doesn't divide 60, say 7, then we just write this cross here to denote that it cannot divide 60, or 60 is not divisible by it. Now note that 0 is divisible by any number except itself. The reason being is because if we have this fraction, so this A divides 0, so this is simply 0 over 8. We know that any number wherein the numerator is 0 would give us 0. So any number here can divide 0 except itself, since if it is 0, say we have 0 here, then we know that this one is undefined. So just take note of that 0 is divisible by any number except itself. So now we go on the divisibility of rules. So we start by the divisibility by 1. So we say that all numbers are divisible by 1. Indeed, if we have fraction A over 1, this simply equals to A. So we know that all these numbers are divisible by 1. So we write 1 divides 75, 1 divides 691, and 1 divides 2, 3, 4, 5. I will go on the divisibility by 2. So we say that number is divisible by 2 if it is even, or it ends in 0, 2, 4, 6, 8. So for this example, this one ends in 4, so we know that it is even, so it is divisible by 2. On the other hand, this one ends in 3, so it is not even, it is odd, so it isn't divisible by 2. Lastly, clearly, this is also even since it is 0, so it is also divisible by 2. Simple as that. Now for the divisibility by 3, simply check the summation of its digits. So what we're doing here is we're simplifying a larger number. So say if we have a big number, say 99999 with so many digits out here, we can simply add its digits and check if that is divisible by 3. So for this example, we know that 6 plus 3 is equal to 9, which is divisible by 3. So we say that 3 divides 63. On the other hand, we have this one, 7 plus 8 plus 0, which is 15 plus 0. It's also divisible by 3. So 3 divides 7, 80. How about the last one? We have 5 plus 2 is equal to 7, which is not divisible by 3. So we have 3 does not divide 52. Now take note that here 15 is divisible by 3, since 1 plus 5 is equal to 6, which is now more clear that it is divisible by 3. So you can do that if the number is still large after applying the divisibility technique. So now for the divisibility by 4, we have that either last 2 digits are divisible by 4 or both zeros. So for this case, since the last 2 digits are both 0, we say that 4 divides 45,800. On the other hand, this one is 28. We know that 28 is divisible by 4, since this will just give us 7, which is the remainder of 0. So 4 divides 7,128. Lastly, we have 8,706. Now clearly, 4 does not divide 6. So we have 4 does not divide 8,706. So what we're doing here is we're simply checking the last 2 digits. Now for the divisibility of 5, simply check if the last digit is either 0 or 5. So clearly, this one is divisible by 5. This one is also divisible by 5. And this one is, since it's not 0 or 5. So we write 5 divides 565. 5 divides 700. And 5 divides 8 does not divide 85. Now for divisibility by 6, we check if it is divisible by 2 and 3. So for this example, first check if is this divisible by 2. Clearly yes, since it ends in 02468. So it's 2. So it is divisible by 2. But is it divisible by 3? Clearly not, since 2 plus 2 is equal to 4. Which is not divisible by 3. So 6 does not divide 22. On the other hand, this one, clearly it is not even, or it is not divisible by 2, since its last digit is 7. But note that when we add its digits, it is divisible by 3. But since it is not divisible by 2, we cannot conclude that it is divisible by 6. So 6 does not divide 57. Lastly, we have 114. Is this even? Yes, since the last digit is 4. Now if we add its digits, we see that it is divisible by 3. So we can conclude here that 6 divides 114. So just take note that for this divisibility to be true, both of these must be satisfied. If it's only one or the other, then it isn't divisible by 6. Now next, for divisibility by 7, this one is more complex, but we just followed this formula wherein it's remaining digits minus twice the last digit. Remaining digits represent the digits except the last digit, so we remove the last digit. So we check if that is divisible by 7. Note that if after applying this, that the number is still large, we can repeat the process until we come with an outcome that is more clear to us. So for this one, we have first remove the last digit out here. So that would give us 4,950 minus twice the last digit, 2 times 4. So that would give us 4,000. 950 minus 8. And this is simply 15 minus 8 is 7, so 4,907. This is a bit clear that it is divisible by 7, since both this one and this one is divisible by 7. But we can still repeat the process. So let's put 4,907 here, and that would give us, if we cut it here, so that's 490 minus 2 times 7. So that would give us 490 minus 14, which is simply 490 minus 14 is 476. We have 490 minus 40. Simple subtraction equals 476. So repeating that process, if it is still not clear, 176 give us 47. We cut it out here. 47 minus 2 times 6 will give us 47 minus 12, which is 35, which is now more clear, since 35 is simply 7 times 5. So thus 7 divides 49,154. Now for divisibility by 8, like in divisibility by 4, now we check the last 3 digits and check if it is divisible by 8 or all zeros. So for this case, since these are all zeros, we can conclude that 8 divides 34,000. For this case, note that we will check this one. So we have 488 divided by 8. This would give us 6, and this would give us 1. So since we found that this is divisible by 8, we can conclude that this one is also divisible by 8. So we have 8 divides 99,488. For the last one, we check this last 3 digits. So we have this one. This would give us 1, bring down the 0, this 1, bring down the 2, and this would give us 2. So clearly it isn't divisible by 8, this last 3 digits, since there is a remainder of 4. So we say that 8 does not divide 12,900. So we check the last 3 digits for this divisibility. Now for the divisibility by 9, we have the sum of the digits are divisible by 9. So like in 3, but this time we check if the digits are divisible. So for this first one, adding its digits, we have 9 plus 1 plus 7 plus 1. So that would give us 9 plus 1 is 10, 7 plus 1 is 8. So 10 plus 1, 10 plus 8 is 18. So this is 18. So clearly this is divisible by 9. It's 9 times 2. So we have 9 divides 9,171. For the next one, we have 3 plus 0 plus 0 plus 0, which is simply 3. Now observe that this one is divisible by 3, but it isn't divisible by 9. Since 9 does not divide 3. Indeed, if we put it in fractions, this would give us 1/3 if we simplify it. Or there's a remainder of 6 over 9. Or 6. So this one is clearly the remainder of 6, just to clarify. So this isn't divisible by 9. So just be careful, since it's often confusing that if we check if it is divisible by 3, we immediately conclude that it is divisible by 9. So just take note of that. So we have 9 does not divide 3,000. Now for divisibility by 10, we simply check if the last digit is 0. So for this case, this one is divisible by 10. This is not, and this is. So we write 10 divides 700, 10 does not divide 651, and 10 divides 5,940. So lastly, we have divisibility by 11. This one is also a bit complex. So we have the difference of the alternating digits is divisible by 11 or is 0. So when we say alternating digits, what we do is this one is grouped with this one and this one. So it's alternating. And this one is grouped with this one and this one. So we add those. So for the first group, say the group orange, we have 1 plus 2 plus 2, and that will give us 5. Second group, we have 3 plus 1 plus 1, which will also give us 5. So clearly, if we get their difference, the outcome is 0. So since it satisfies our statement, we say that this number is divisible by 11, or that is 11 divides 132,121. So now just an additional tip. So to check divisibility, if it's greater than 11, so 12 and above, note that some of these have still other rules such as 13, since we just tackled the basics, but for most cases, we simply check if it is divisible by its co-primes. So say if we are given 15. First let's define what co-prime is. Co-primes are numbers without similar factors, except 1. So say if we have 9 and 5, or let's say 4. 9 and 4. Even though these two numbers are not prime, since this one is divisible by 3, this one is divisible by 2, if we check their common factors, their only common factor is 1. So indeed, this is 3 times 3, this is 2 times 2, it's 1. So they don't have any common factors. While if we have 9 and 3, these one are not co-primes, since their common factor is 3, not 1. So for this example, we know that for 15, their common factors, their common factor that is co-prime is 5 and 3. So we simply check if this one is divisible by 5 and 3. Where clearly it is divisible by 5, instead, as we said a while ago, it must end in 0 or 5. So it is divisible by 5. And also it is divisible by 3, since 9 plus 0 is 1. 9 plus 0, which digit is 9, which is divisible by 3. So we conclude that this is indeed true. So 15 really divides 90. Now for this next one, the co-primes of 45, the factors that they have is 9 and 5. So we know to get the divisibility of these two numbers. So clearly it is again divisible by 5, since its last digit is 5. So also note that it is divisible by 9, since 1 plus 3 plus 5 will give us 1 plus 3 is 4, plus 5 is 9. So 9 divides 9. So this is also indeed true. So just use this tip for numbers that we aren't sure how to get the divisibility, but it's we can factor some known divisibility rules on it. Like in here, we know the divisibility rules for 3, 5, and 9. So that's all for this video.